In this video, I'm going to do an applied example of using the stack in Java. Let's just remember what a stack is first. A stack is first in, last out. So the first one in is this item down here, then the next one in is this item down here. If we say first in, last out, that means the most recently added item will be the one that's removed. So if we add a couple more items to it, to our stack, and then we need to pull something off, those which were added most recently are going to be removed first. Add another item, and that one will be the first one to go. Now, what are some good examples of this? Well, one of them is Control-Z. You know, on Control-Z, it takes the most recent operation that you did and removes that or undoes that. I often think about plates on a salad bar, too, where the clean plates, the server will come out and put them on the stack of plates, and you know, the one you grab is the one that was most recently washed. A couple other situations we have. One we saw recently is the method call stack. This is a screen capture from a previous video I did where I was showing recursion. And you see that every time we call a method, it goes to the top of the stack. And a really handy thing about our IDE is we can do what's called drop to frame, where we can go back in that stack and restart our debugger at a certain point if we want a do-over without having to start from the very beginning. Now, another good use of stack is in accounting. In accounting, there's several different ways that we can account for inventory. There's first in, first out, which we know with the queue, then modified accelerated cost recovery system. There are a couple other things like that. But LIFO is another way we can do accounting, where we say, let's say we have an inventory of stuff, and we need to value that inventory, and the value of those raw materials change over time. Well, last in, first out means whatever we most recently purchased is the one that we're using, and whatever is left over there is basically taken at the value where we purchased it originally. That probably sounds confusing, doesn't it? So let me put it to you this way. If you're like me, you fill up your tank of gas when you get to about a quarter tank. And in my truck, which I've had for about 10 years now, I don't think I've ever gone down below an eighth of a tank, but almost always I have refilled at least a quarter tank. So in theory, there's gas in my truck that might have existed from a valuation basis from the day I drove the truck home and got my free first tank of gas from the dealership. So that's the scenario that I want to look at here, which is computing the value of gasoline that's remaining in the car on a last in, first out basis, which means if we have a quarter tank or whatever we have, we're going to assume that that is basically the original gas or the oldest gas we ever put in the truck. And every time I filled it up, that's the first to be used. Now, of course, it all gets mixed in together in the tank, so it's not like I have 10-year-old gas in my truck. But what we're considering now is the valuation of that gas. What's it worth? So let's take a look at our program. I'm going to allow us to add gas to our vehicle when we first create it. So I'm going to need to add a few components to our JFrame that we created earlier. So now you can see that I have an add gas option here, and I have a price per gallon, and then I have add gas over here. So that will allow me to add gas in multiple instances as I'm creating the vehicle. And I'll go ahead and add an action listener to this add gas button. We will come back and fill this out in a bit, but first we have to do a couple of other things. We need a DTO or a data class that represents our gasoline. And as you see here, it's fairly straightforward. It simply has gallons and price as two attributes. Now, let's go to our vehicle, and we're going to need to make a few more changes here. First, we're going to need to make a stack that's going to hold these gallons of gas. And we initialize it just like so. Let's create a getter and setter for this because we're going to need to populate this from our form. Now, a couple tricky things we're going to need to do. I still want to keep gallons of gas as an attribute in this class. Remember that so far we just have a number, which is gallons of gas. And actually, I could just read that from the stack, but that would require iterating over everything in the stack. And I itch at that a little bit because it is storing data in two different places. But for simplicity, I'm going to keep it there. The other thing is we need to change our go method so that when we decrease gas, we're pulling each of these fill-ups off the stack. And it's actually going to be a little bit tricky because let's say that we added 3 gallons of gas and then 5 gallons of gas and then 2 gallons of gas in that order. And we need to consume 4 gallons of gas. Okay, well the 2 gallons, they're gone. But then that middle 5 gallons, we need to take 2 out of it. Well, that's actually okay with the stack because what we're going to do is a peek operation, which will allow us to look at the item at the start of the stack and see what's in it and see if we need to pop that. We'll pop it if we've consumed all the gasoline. But if we've not consumed all the gasoline, we'll simply update the state of that object and leave it on the stack. So kind of a good use case for a stack, but it's going to be just a little bit trickiness we need to do. After that, we're going to need to update the toString of our vehicle to reflect the average cost of gas or the total value of gas that's in the tank. Let's start with the go method. First, I'm going to try and make things a little bit easier by simply figuring out how much gas was consumed, which I actually have in this set gallons of gas operation right here. I'm simply going to pull this out and save this into a separate variable because I know I'm going to need it later. Next, I'm going to put in a do-while loop, and we know a do-while loop is guaranteed to run at least once. The do-while loop is going to take this total gallons consumed, and it's going to do a peek operation on our stack, which looks at that item that's next to be removed from the stack, but doesn't actually remove it. And we're going to do a comparison to see if there's enough gas in that first item to satisfy this equation. And if there is, then we'll consume it, and if there's some left over, we'll leave it on the stack. But if we find that we consume all of it and we still have more left over, we will take a look at we'll go ahead and pop that item that's on the top, and then we'll peek at the next item, and we'll continue to do this until we have consumed or allocated all of the gas that's been used. So a few things that we need to consider in our do-while loop. First of all, I do a peek operation to just get a reference at the item that's next to be removed from our stack, which is this gas item that the detail that we created earlier. Now, there are really 3 outcomes. It could be that the gas consumed in this journey is exactly equal to that gas in our peek operation. I call that gasoline and peek, and unfortunately, I have a whole bunch of variables named gas, so I had to give them a little different name. So in any case, let's say the gallons consumed is exactly equal to what we got from this peek operation. That's the simplest of all. Then we simply pop that item off the stack and it won't be used again, and we're done. Now, let's say that our gallons consumed is less than the gallons in peek. So maybe our last fill up we added 5 gallons, and in this trip we're using 3. In that case, we're simply going to leave that item at the stack, on the stack where it is, but we're going to decrease the gallons available there. So we'll say, okay, let's take that 5 gallons, subtract the 3 that were consumed, and that leaves us with 2 gallons for our next journey. Now, the last operation we have is where the gallons consumed is greater than the gallons that are available in that next item on our stack. And in that case, okay, what we need to do is decrease the gallons consumed by whatever's in that stack. So let's say this time maybe we used 5 gallons of gas. The next item on the stack is 3 gallons. So we're going to say, okay, we can account for 3 of the 5 gallons that were consumed on this journey, but we're still going to need to find the other 2 somewhere else. So we decrease the gallons consumed to say we need 2 more gallons, and we go ahead and pop this item off the stack. Now, because gallons consumed is 2, which is greater than 0, this while loop will execute again and run that same logic all again on the next item in the stack. I need to add one more thing. I need to make sure we terminate the loop. So if we have this first case where we consume exactly everything in that first object, let's go ahead and set gallons consumed to 0. And you know what? It's going to be the same deal on that second case because we were able to satisfy our gallons consumed entirely with that one peek operation. So we want to go ahead and terminate the loop then as well. So add these 2 lines and we're good. The next thing we need to do is come up with some computation to compute our average gallon of gas price and maybe the total gallons of gas in the vehicle. So make a couple of operations for that. So I have two operations here. Compute total gas value is iterating over our stack, which we can do. We can iterate over the stack and leave everything there just like any normal collection. And we're adding the total value by multiplying the gallons of gas in each of our gasoline objects times the price, and then we return that value. So that's the total value of all the gas in our tank. Now, the average value is going to be similar. We're going to go ahead and compute that total value, but we're also going to separately compute the number of gallons, and then we're going to return the total value divided by gallons, which will give us our average cost per gallon. Now we go to our toString, and we can add these terms. Now we simply need to go back to our form and complete that operation where we are adding gas. Now, ideally, I'd like to add the gasoline directly to the vehicle, but there's a little bit of a trick here, which is we have to add this gas and get it all together before we actually create the vehicle object. So I'm going to need to make a stack in this form, associate it with the vehicle, and then I'll need to clear that stack each time I save the vehicle. So you see here, I'm simply grabbing the values of gas added, price per gallon, parsing them to a double, creating a new gas object, adding these items to the gasoline object, and then adding that to the stack. Now let's take a look at the save operation. And we store this stack into our vehicle. Now down below where we clean things up, let's go ahead and reinitialize that stack. And let's not forget to clear out the fields as well. Now, it feels a bit redundant to prompt for gas here and prompt for gas up above. I'll eventually refactor that and remove that, but for the time being, I'm simply going to ignore that gallons of gas. Let's go ahead now and debug and watch what happens. I will add 4 gallons of gas, let's say $2 per gallon. That'll be the first time we filled up. And you notice in this action performed, it's gathering that data that I entered on the form, creating a gasoline object, and then pushing that object onto our stack. I'm satisfied with this now, so I'm going to go ahead and turn off that breakpoint. Now we'll add another 4 gallons of gas, but this time let's make it, say, $4 per gallon. And we choose Save. So when we save, note that we're taking the stack we've been building up and we set that on our vehicle. I should see 2 items in this stack, and sure enough, there are 2 items. Our first fill up and our second fill up. So the fill up at $2 per gallon for 4 gallons, and the fill up at $4 per gallon for 4 gallons. And now it's going through, it's doing the toString, so it can show this in the list. So now it's going through and iterating over all of the gasoline in that collection to come up with our value, our average gas value. And we'll see in just a moment also our total gas value. Now let's see, we have average cost per gallon is $3, which makes sense. Because we had 4 gallons at $2, 4 gallons at $4, that would average out to $3. Now, total cost, I should say total cost of gas there. So 2 times 4 is 8, 4 times 4 is 16, 8 plus 16 is 24, and so far this adds up. Now, I believe we said 20 miles per gallon, so if we run this by 100 miles, that will consume all of the first bucket of gas. So that was 4 gallons, right? And then 1 gallon of the next bucket of gas. Let's watch this. So here we are in our go method, and you notice that now we're doing this peak operation. And we're going to say, okay, how many gallons are in this first item? And we have 4 gallons. And how many gallons are consumed? 5 gallons. So the first test we're going to have is the gallons consumed is greater than gallons in peak. So we update the gallons consumed, which is really what's left over that we have to get out of another object. And we go ahead and pop this item off of the stack. Now, because gallons consumed is not 0, it's going to iterate one more time. And this time it's going to get the next item that is on the stack. And that next item, I believe, is the gas that was $2 per gallon. Let's see. Yep, sure enough, $2 per gallon. It's going to consume 1 gallon of that and leave 3 more. So if we take a look at this gas object, we'll see that the gallons has been updated to 3, but it still lives on the stack. And because we've accounted for all of the gallons we've consumed, we can go ahead and let this play. Back to our driver form, we see what's interesting here is remember last in, first out. So the first thing we added was $2 per gallon for 4 gallons. The second thing we added was $4 per gallon for 4 gallons. We consumed 5 gallons, so we wiped out all of that $4 gas allotment, and we consumed 1 gallon of the gas that costs $2 per gallon, which leaves us with 3 gallons of gas left in our tank. And we're valuing that at the initial fill-up, which was $2. So if we take a look at our output, we see our average cost per gallon now is $2, and the total cost is $6, because 3 gallons times $2, $6. Okay, let's try and drive this by 60 miles, which, if I'm doing my math right, should consume the remaining gallons that we have in our tank. So once again, we're in our go method. We're going to peek at the item that remains on the stack, and in this case, there's only one item on the stack. And we see that it's our gasoline object, and 3 gallons are there. And gallons consumed is what? Hopefully 3. It is 3. So now we're at this equal state where there are exactly 3 gallons consumed and exactly 3 gallons in this object that's on our stack. So we're going to go ahead and pop it off, reset gallons consumed to 0, and terminate the loop. And we go back. We have kind of a funny readout here. We have average cost per gallon, not a number. That's because we try to divide by 0 because there's 0 gallons left, and total cost is 0. So in this video, we've seen how to implement a stack to give a last in, first out approach that is frequently used in accounting. And in this case, we are accounting for the value of gas that's remaining in our gas tank. So now I have a little bit of refactoring and cleanup I need to do on this, but nonetheless, I do hope this video was helpful. And as always, I look forward to reading your comments. Thank you.